Okay, so up to this point, we've been through like what are vectors, what are matrices, and what are arrays. Now what we're going to look at is the data frame, and the data frame is something you're going to use all the time. You can think of a data frame as similar to like an Excel spreadsheet. So you basically have rows and columns where the rows are generally like individual records, and then the columns represent attributes about those records. So if you had, for example, like information about students, you might have like each row being a specific student, and each column is some information about that student. So it could be like their age or their academic year or their GPA or their home address or whatever, right? You might be thinking, what is the difference between a matrix and an array? Because they're both a matrix and a data frame, because they're both basically two dimensions. Well, the main difference is that a data frame, you can have different data types in each column, similar to like an Excel spreadsheet. So you could have like a numeric column, a date column, a text column, a Boolean column. They don't have to be all the same data type. Okay, so basically when we work with like table data, we generally read them in as a data frame. So that's one of the reasons why you're going to get used to seeing data frames. If you are a Python user, this is basically the same idea as the pandas data frame. In fact, pandas data frames are kind of originated or built on top of the philosophy of the R data frame. One of the key differences, though, is that the data frame in R is native to R. It's not an add-on like data class like it is for Python, via the pandas library. Okay, so here's just an example of building a data frame from scratch. So first thing I'm doing is I'm creating some data that will represent the different columns. So this is some information about a course. So I basically have the course prefix, the course number, the course name, and then the enrollment for the course. And then to merge those into these vectors into a single data frame, I basically just use the data.frame function, and I list out all of the columns, and then I just print it. So if we run that, you can see what we get back here is this data frame object. So we have the prefix, the course number, the course name, and the enrollment in the course. Okay. Next thing we'll look at with the data frame is doing subsetting, and since this is basically two-dimensional, it's going to look very similar to how we did the subsetting or indexing for a matrix. So the value before the comma represents the rows, and then the after represents the column. So what this is going to do is pull out everything in column 1. This is going to pull out everything in row 1. This is going to pull out the value at row 1, column 3. And again, since we have names associated, we can use the name. So this is just going to pull out all the values that are stored in the course name column. Okay, this is another way you can do it. So the $sign allows you to grab objects from inside of a larger object. So this is the data frame, and then this specifies the column from the data frame. So this is the course name column in the course data frame, enrollment column in the course data frame. Right, so if we run those, see what we get back here. So the first one is basically row 1. Sorry, this got truncated. Let me throw this down in the console here so we can see the whole thing. Clear my console out again. Okay, so that was column 1. This was row 1. This one was row 1, column 3, so just a single value. This pulls out all the course names, which is a column, all the data from a specific column. And then this was using the $sign there, so all of the course names and then all the enrollments. One thing to note, just let me grab like this again. You can pull out like a column from a vector and then from a data frame and store it as a vector. So we'll just call this CNames. And we'll set that equal to, now instead of print, we'll do, actually I think it should just work if we do it this way. Let's see if that works. So now we should have this object cnames, and that's the list of course names as a vector. So you can save out like a single column or even a single row as a vector object, for if you just need it, as opposed to the whole data frame. Okay, so the next type of data object we're going to look at is a list. Be honest, I don't generally create a lot of lists like on my own, but I tend to use a lot of lists that are created as output from something else. So for example, if you run like a linear regression model, it's going to create a list object that has different, like the different outputs as different components in the list. So like the residuals, or like the r-squareds, or the like coefficients or whatever. So if you're a Python user, a list is kind of similar to like a dictionary, like a Python dictionary. So what's kind of different between this and like a data frame is that each element in the list can hold different types of data. So one element could be a vector, another one could be a data frame, another one could be a matrix or an array. You can even have lists that are elements inside of other lists. Okay, so let's have a look at that. So this is an example of just setting up a list with some different components. So first I'm creating a vector, and I'm doing this with this sample function. What the sample function does is it basically creates random samples. So I'm saying from 1 to 1,000, randomly select 50 values, and replacement equals true means that it's like random selection with replacement, so you could sample the same value more than once. And then our norm here basically grabs a certain number of records, in this case 200, from a normal distribution with a defined mean and a defined standard deviation. Alright, so basically those are two ways to create a vector. And then for the data frame here, and then this is just using our combine function, so it's basically a list of values, and then I'm defining R name and C name here, and then I use those to create a matrix. And then here we have another data object I'm creating with the sequence, so 1 through 150 by 2, so like 1, 3, 5, 7, so on and so forth. These are actually objects we create above. I'm just recreating them here. And here we're making a three-dimensional array. And then now I merge all those into a list. So in the list, each of the objects can have a name. So I'm basically setting vector1 equal to the vec1 object, vec2 to vec2 object, so on and so forth. And then once I've created the array, then to actually call its components, I can use the $sign. So to print vec1 from list1, I can just use the $sign here. And then if I wanted to pull specific features from the array, in this case, I can just use indexing. So this is going to pull the value that's at position 1 and dimension 1, position 1 and dimension 2, and position 1 and dimension 3 from array 1, which is an object which is inside of list 1. That's the idea. So if we print that, see what we get back here. So this printed back our array, our vector there. I think it maybe truncated it. I guess it didn't. This is vec1, which was, it was 1 through 1,000 by pick of 50 random with replacement. So these were the values that it picked, and this was the value at position, all the 1 positions in the array, which is in the list object. So just as a couple other notes, like if I wanted to let's like print the whole array, it would just be like list1 $sign array1. That would print the entire array. So basically the list kind of acts as a container that can hold a wide variety of other objects, right? And then you can dive into the object to pull out sub pieces of it. Okay, just as a side note, there are like special types of objects in R that are defined using different data structures. So there's like S3, S4, S5, We're not really going to get into this in here, but I did want to at least mention it. If you're used to Python, this is similar to the idea of defining a class and that has specific like properties and methods that are going to be applied to it. So if you want to like work with a specific type of data in R, then you can define like a new like data object by creating a new class or subclassing an existing class. So that really expands what you can do with R. And again, we're not going to get into that, but I did at least want to mention it. That's kind of like the object-oriented component of R.